All right, welcome. I'm Ryan Holger with TEC, and today I have with me Frank Stamatatos from SecureAire. This is a very timely topic, obviously. We've done the residential version of this discussion a week ago, but now we want to talk about the commercial side of it. We've been doing these commercial products with Frank and his company for, I don't know, 6, 7 years, mostly hospital stuff, but also some other commercial projects. So with it being very timely and a lot of hospital infection work going on right now, we wanted to invite Frank out to kind of run us through it all again. So Frank, I'm going to turn it over to you, sir.
Okay, great. Thank you, Ryan. Appreciate it. So good morning, everybody, and thank you for joining us. Just a matter of housekeeping and a matter of introduction. From a background standpoint, I actually have nearly 35 years experience in filtration. So my positions are typically based on fact and having used the technology somewhere, sometime, somehow. From a SecureAire standpoint and the recent pandemic that's happening in the world, as Ryan said, this is actually very timely, and we just want to kind of share information with you that we've been sharing for some time now. So when we look at, or when we talk about indoor air quality, numerous studies out there in the marketplace that actually speak to indoor air quality and how it affects individuals or people. This particular study talks about indoor air quality and the link to productivity. A lot here, and of course we can provide you with copies of these particular studies. The second study is actually groundbreaking from our perspective because it links directly indoor air quality to brain function. That's significant. And when we look at the third from the end, or the end, you can see that in a normal building environment, this is where your brain functions. And in an indoor air quality that's very high, the difference is nearly 300%. So the difference in cognitive brain function, that's very big. And this study was actually backed by the National Institute of Health. So maybe more timely now than previously shared, this talks about transmission of infectious seasonal influenza. So the flu, and how do you get it? We've previously thought that somebody had to cough or sneeze in your direction. Of course, we know a lot more now and a lot more people looking at it. And now the response is, well, all you need to do is actually breathe. The problem here is not outside. The problem here is inside. So when you're in an indoor environment, it becomes more and more critical that somebody that's infected actually has the virus in their exhale. And this was a study that was done at the University of Maryland a number of years ago. When we look at how do we measure air quality, the best way and the most cost-effective way to measure air quality is by measuring particles, period. Another study by the National Institute of Health talks about the relationship between measuring of particles and viable airborne contamination. Viable airbornes in this case are bacteria, so a little larger than viruses. But from a healthcare perspective, we want to look at both. And what the National Institute of Health found in this particular research that was done, again, a number of years ago, is that there's a direct correlation to particle counts and viable counts. This is what we're after in our healthcare institutions, is how do we reduce the number of viable counts? When SecureAire first started, when I came to the company about 7 years ago, our mission was, how do we actually reduce hospital-acquired or healthcare-acquired infections? And as we all know, the United States is the #1 country when it comes to healthcare spend. We outspend more than anybody else in the world, and we still have something that's called a hospital-acquired infection. In addition to hospital-acquired infection, we know that basically 1 in 10 people in our country have asthma, and there's a lot of premature deaths now linked to indoor air quality. The last one we're not going to spend a lot of time on, but air contamination or air pollution is also linked to other diseases, and they don't necessarily have to be respiratory in nature. So what is our industry doing? Well, our industry to date is utilizing mechanical filtration to remove contaminants. The problem with that is that there hasn't been a significant breakthrough in technology in over 80+ years. The last breakthrough, which was the Hepa filter, was invented in 1942. So we need to look at things a little different. So again, conventional methods are passive. They sit in our air handlers or our home systems, and they wait for the airborne contaminants to get to it via airflow. But the question is, what happens if the particles don't get to the filters? Are they actually working? And we're going to see that today we need systems that are active. Active is extremely important in the ability to actually move, capture, and inactivate or kill airborne pathogens, which include virus and bacteria. What you'll see in the next couple of slides is that SecureAire has developed a technology that not only captures critical airborne pathogens, but once it captures them, it kills them. Our industry has been looking at indoor air quality for some time. These are just 4 different papers that have been published in our industry journals. It's always worth going back and looking at some of these studies. It's it's material that's really actually ahead of its time. And with the recent world situation, of course, more salient today. So, hospital-acquired infection, where do they come from? What's the burden on the system? Well, we know that there's typically a 1.7 million cases of hospital-acquired infection registered every year. And out of those 1.7 million cases, nearly 75,000 patients die. So there's a big burden on our healthcare system. The problem is, where do they come from? And today's environment is telling us a different, very, very different story. We always thought that the majority of infections were caused by touch. Now we know that airborne transmission plays a much larger role. And some suggest that it could be as high as 80 or 90%. From an airborne perspective, numerous different things have been linked to airborne disease transmission. So today, we're talking about cleaning surfaces. After you clean a surface, are you done? And the answer is you're not. You have to continually clean that surface. Why is that? It's because the surfaces are being reinfected from airborne contaminants. Here's probably the most salient position relative to infection and HVAC. So the science for controlling infections caused by airborne microorganisms is a complex mixture of engineering, particle physics, microbiology, and medicine. Notice that medicine is listed last. This is an engineering and particle physics issue. To the last sentence, particles or aerosols less than 1 micron in size are virtually unaffected by gravity and are suspended because of Brownian motion. This is it. Here you have it. This comes from the ASHRAE 2013 Design Manual for Hospitals and Clinics. That sentence is so important to understand. Small particles are actually dangerous, and if we don't find a way to get them out of our buildings, we have what we have today. 3 to 6 feet, social distancing of 6 feet. Where did that number come from? Well, it came from here, basically saying that aerosols generated by a cough or a sneeze only affect persons within 3 to 6 feet. Well, I have news for you all. It's not 3 to 6 feet. It's actually about 200 feet. So our social distancing of 6 feet, that's outside. Inside, it's a completely different story. And there's been more and more research that you can actually track. We've shared it with a number of our commercial representatives that even 30 feet isn't safe enough. When we look at designs for critical environments, all of you would agree that these 7 items are critical. But if these 7 items work in the design of our systems, why do we still have the high rate of infections in the United States? One way that previous industries have removed small airborne contaminants is by an enormous amount of air changes. They force the contaminants out, but they also strictly limit the amount of time people can spend in a room. So from a design standpoint, we believe that active particle control is critical to the ability to clean an indoor air environment. Because, of course, we cannot afford 650 air changes an hour in our buildings. So Conventional methods. There's a weakness to all conventional methods. If we look here, this is an operating room with our patient, and above the patient is called the critical zone. And when you look at computational fluid dynamics and track the path of small airborne contaminants, you'll notice that they all reside in a very, very bad place. They're all in the critical zone. So if critical airborne contaminants do not get to the filters, do the filters work? That's the question you have to ask yourself. It doesn't matter whether you have a Hepa, an ULPA, a MERV 1514, whatever you want to put there. If the airborne contaminants don't get to the filters, they're not being very effective. So here's our chart. If you look at the top, conventional technologies remove 2.5 micron and larger airborne contaminants. When you look at the critical particles, which are ultrafine and fine in size, this is where your HEPA filters don't work very well, because most of these guys float in the space. And you'll notice down here that the COVID-19 virus is extremely small. Now we understand why this has developed how it has developed. Just cleaning your surfaces isn't enough. You have to scrub the air, and that's what SecureAire is all about. So, does particle size matter? If we look at the average human, the path to breathing is typically down into the lungs. The problem is when you have the ultrafine and fine particles, they don't take the normal path. Sometimes they actually go up through the olfactory nerve behind your nasal cavity and actually deposit into your brain. This directly connects the indoor air quality studies that we shared earlier to airborne contamination having effect on brain function. So if we look at a cubic foot of air, there's roughly 20 million particles in a cubic foot of air. You'd be surprised to know that airflow affects a very, very small amount. The majority of airborne contaminants are being held by an electromagnetic field that exists in our building. As soon as we put a roof on a building structure, you've now created a field. And that field is more dominant on small airborne contaminants than airflow. And what SecureAire has done is it's found a pretty unique way of pushing those particles to the right so that airflow can be our transport mechanism. If you fail to unlock the hold from the field, your small airborne contaminants remain. And how long they last depends upon a number of factors. One of the best ways is to actually keep your humidity levels between 40 and 60%. Very recent studies suggest that in the winter months, when the flu goes into its peak, most of our RH readings go below 40%, and they get to actually around 20. And at 20% RH, viruses become more deadly. Another passage from the design manual from ASHRAE. And what they're basically saying is that there's a lot of new technologies that are focused on indoor air quality. But it's very hard for us to help you identify which works and which don't. From our perspective at SecureAire, we give you the tools to do it. So we just want to share with you also some very, very recent information. SecureAire was recently published in the American Journal of Infection Control for its technology. Ryan will be glad to send you a copy of the article, and it pits SecureAire technology against Hepa filtration. In addition to that, at a respiratory healthcare system in New York, St. Mary's Children's Hospital, last year, we installed a system in the majority of their building. And we'll update this slide, but as of last week, we have prevented 45 children from being infected as opposed to the prior year. So we have 90 parents that are pretty happy at this moment. University of California, Davis Medical Center. They did a test a number of months ago in their cancer compounding pharmacy. Very, very significant results from their perspective. And at UC Davis Medical Center in California, they are using SecureAire systems in their COVID-19 pods. We'd also add MD Anderson Cancer Center. And right now we're actually working on some hospital build-outs in Boston, Massachusetts. So our technology is proven, it's been validated by other third parties, and we don't believe there's an equal product on the market today, period. Well, why do we say what we say? Well, we actually measure airborne contaminants, and then we show you the ability to reduce it. Not in a day, not in a week, not in a month. In 15 minutes, you'll typically see about a 50% reduction right around that portable unit. Product portfolio. So what do our products look like? How can we apply them? We have built up air handler systems that you see on the left, a portable unit. We've got an in-duct system, and of course we have an air quality monitor. From the residential standpoint, some of you saw our residential presentation last week, and we're now moving into a residential portable unit as well. That product is to be introduced and launched in the end of the second quarter of this year. So how does the technology work? Well, most of you learned this around the 3rd or 5th grade. It's actually very simple. It's based upon likes and unlikes. A little more depth. We use both positive and negative charges. And with those positive and negative charges, we force collisions. And of course, when two smaller things come together and collide, they get larger. And when things get larger, airflow can help us remove them. So that's the principle for what we do. Positive and negative charge, forcing collisions. So if we look at a system, I believe that we all understand that there's no air filter that's 100% efficient. It doesn't exist. So what we do is utilize what gets through the filters to help us clean the space. So we condition with charge. We force collisions. And what we create are net neutrals that exit the system. This is actually very important because if it's not net neutral, it will stick. And we don't want things to stick to our surfaces. We want them to be removed from the treated environment. Of course, particles are more easily captured when they collide and are net neutral. And the huge advantage of SecureAire is that anything that we capture that's viable, it can't continue to live. And when we talk about a virus in this context, as you all know, viruses are not living things. Viruses need a host to live. So what we do to a virus is we actually inactivate their ability to replicate. And our process helps us to clean the space, and we have plenty and plenty of data to back it up. So, speaking of data, Lake Tahoe Surgery Center, this is a case study on our website. You can see particle loads dramatically reduced. In addition, TVOCs dramatically reduced. So how can a filtration system that removes particles also look at VOCs? By the way, Lake Tahoe Surgery went to a hospital infection rate of 0 for 3 years in a row. And they started at roughly 4.5% to 5%. We are one of the first companies a number of years ago to link infection rates to airborne contamination. Another test, a lot of data. Again, red line without SecureAire portable unit rolled in for the next day. This is a 2-day time study, and 76% reduction in an operating room. Why do we have infections? Because you can cut down 76% of airborne contaminants with an appropriate technology. This study is part of our American Journal of Infection Control paper. We had 2 different operating rooms, very similar air handlers, MERV 14 Hepa. A lot of folks designing air handlers for hospitals. There we go. One difference in the other air handler. We took the Hepas out, we took the MERV 14s out. Significant reduction in airborne contamination. If you had to be operated on, which operating room would you want to be in? That's the question. multiple studies. This is a study that was done in Minnesota by Dr. Arif, who is on our healthcare advisory board. This was a 3-week study with a baseline established and different types of surgeries. The second week, SecureAire technology was put in, significant reduction in airborne contaminants. Particle reductions lead to the reduction of viables. Remember from the beginning of our presentation, they're directly linked. This is a summary chart. Interesting to note that when we took the SecureAire unit out, particle count started going back up. So we know that the SecureAire technology works. And it's by data that we say so. This was a compounding pharmacy where they actually mix cancer drugs. And the reason that we were called is that this pharmacy was actually shut down. They were shut down because of high airborne contaminants. We rolled in a portable unit, and in 3 days, they had this pharmacy back up and running. The left side, particle count reductions. The right side, CFU count reductions. Particle counts and CFUs are directly linked. Our ability to kill. Study was done at the University of Colorado on the anthrax surrogate. If you can kill the anthrax surrogate, viruses and bacteria are easy. Another study talks about carbon monoxide reduction. Not going to spend a lot of time here. What's very, very important to note is that the same technology reduced carbon monoxide levels from above 9 parts per million to an average of baseline. Again, this is a case study and available for your review. So hopefully you understand now that there's an electromagnetic force that works on small particles. Airflow is not the main cause and effect on small particles. It's electromagnetic forces. And if you don't break them, you don't remove small contaminants from your treated environment. And if we look here to the right, there is something in that red circle. And in that red circle, you would be surprised to see that we have mold growing on the downstream side of a Hepa filter. So how does that happen? Well, as we know in the HVAC industry, we never have water inside of an air handler. That, of course, was a joke. If you have mold and a source of nutrients and moisture, that can happen. And that is, of course, a bad thing, specifically inside of a hospital. So if you cannot stop that from happening, are you actually helping the systems? So again, looking at the typical SecureAire system, it's 9 inches deep, high performance, low static pressures. So it's relatively easy to install in a new system or an existing system. It's not going to fit in your rooftop units. But as you saw earlier, there are other ways to adapt the technology. There are different benefits of the systems, including static pressure, which is an energy contributor, and the life of our filters actually typically lasts 2 times longer than typical mechanicals. And that happens because our filters sit in an electric field and they don't face load. Most mechanical filters face load. SecureAire filters do not. Brake horsepower, again, probably worth a discussion, but more importantly today, we're focused on the ability to actually clean the space from airborne pathogens. Engineering support programs, we have numerous ones, a lot of different case studies, and proven, measured, and verified technology. So, if we were to summarize what we talked about, we have a solution that we believe is equal to none. It has numerous benefits beyond indoor air quality. And the technology doesn't care what the airborne contaminant is. Virus, bacteria, smoke, odor. It doesn't discriminate. It doesn't know what it is. All it wants to do is reduce it. So Ryan, I think we're nearing the end of the presentation. I think we kept it relatively short so that we could field questions and provide hopefully some intelligent answers.
Awesome, Frank. For you guys watching, if you could, any questions you have, type them in that question box down in the bottom right-hand corner, or maybe labeled as a chat box on your end, I'm not sure. But type it in there, and I will read it out to Frank. There's like 140 some people on here, so I can't really unmute you. It would be chaos. So you got to type them in, please. Go see if there's any in here yet. Several people have asked if they can get copies of some of the PDFs that you had shown. I assume that's more like the case studies and stuff. So yes, we can get you that.
Absolutely.
Jeremy asks, what are the options for rooftop systems?
So there's a couple of options for rooftops. One is to actually install the systems in the curbs, but that's really the option today. The other option is the ability to put those ducted systems into the space and just recirculate that space, or portable units.
Awesome. And obviously the curb thing only works if you're going to have a crane out there and you're changing rooftops. So it's more of a planned thing in that regard, obviously.
Correct.
Jay asks if you can talk about reduction in brake horsepower.
Okay, so exactly. So we know that a lot of designs, you're fighting for brake horsepower. And what we've found, because our static pressure is typically a half to 65 or 66% less than mechanical filtration, is that your ability to actually decrease the size of the equipment does exist. Now, most people don't like to do it, because they want to over design a little bit in case you get expansion in the building. But in fact, it's been our experience that you can actually, if the situation is correct, actually design your systems to be slightly smaller.
Okay, next question, Frank. Mike asks, is the residential technology the same as the commercial technology?
It is. The platforms are exactly the same.
All due to the shrink ray. Nate asks about recommendation about where to locate the portable unit in a room in regards to proximity to patients and things like that.
Okay, so that's a good question. So the way that the technology works is that the closer you are to the unit, the cleaner the air is. That being said, the more time you have that unit in the space, the further the plume of cleanliness expands. So in this case, where we are today, they're not necessarily concerned with protecting the patient. They're actually more concerned with protecting the healthcare providers. So that unit just being in the space where patients are being treated offers you a pretty inexpensive additional insurance policy over the gowns and the masks that a lot of the healthcare workers are wearing. Think about it, if you can reduce the airborne contamination by 90+%, your statistics just got a lot better.
All right, next question. Eric's got a long one here. Is UC Davis sharing any info on the portable units? Can you provide any info as to how position your patients, which you've already answered, and where they're using them, what type of rooms, ICU, triage, tents, etc.? Is UTC, oh, then he just repeated it. I think he must have cut and pasted. Okay, so I guess the only additional question is UC Davis, what kind of rooms are they using them in? Triage tents or what are they doing?
Yeah, so right now they have what they call their COVID pods, which is where they treat patients that have been infected by the virus. So those units are actually physically in those treatment areas. And again, the main purpose is actually to protect the healthcare providers.
All right, Eric asks, the amp draw is low. What should it be? Not sure. That's
so it depends upon. Yeah, so it depends upon the size of the system, but the amp draw is extremely low. That's correct. So typically, the draw for a 30,000 CFM system is somewhere in the neighborhood of 75 watts. So the power consumption of SecureAire technology is extremely low.
How much space can a portable unit treat? Doug asks.
So the APS 1000X can treat roughly 1,000 square feet. And that would give you extremely high quality air in the neighborhood of an ISO class 7, ISO class 8 clean room.
All right, Susan asks, is there any O3 that'll be created as a byproduct?
No.
Saeed asks, what about furnace systems for residential applications? Just so Saeed and everybody else knows, we did do that webinar last week, and we did record it on our website if you want to dive into that. Obviously, Frank mentioned the technology works the same, but installation, mounting, and that part of it's obviously different. If you go to tecmungo.com and click on training, you can watch any of those recorded webinars. Jim asks, how does this technology compare to bipolar ionization for effectiveness?
So we believe that there's no comparison. And you would expect me to say that. Our process we call active particle control. And in this case, the control being the most important aspect. So if you look at ionization systems, they're blasting spaces with ionization to create reactions. SecureAire technology does not work in the same way. Our process is controlled. We don't want ionization in your face. So our process is remove the contaminants from the space, and then if they're viable, eradicate them. The question you need to ask yourself is, do you want reactions where you breathe? And for me, the answer is I don't.
All right, the next question is from Steve. Is this an electronic air cleaner technology that one might have in a residential system? It sounds similar when you talk about putting a charge on particles.
So this is, if you will, an electrically enhanced system. And are they similar to others? Maybe in definition alone, but that's where it stops.
Keith asks if you can expand on the word inactivate that you've mentioned a couple times.
Okay, so inactivate is our process of killing viable pathogens. You can kill a bacteria or mold because they are living. You cannot kill a virus because technically it's not alive. So what we do to a virus is we inactivate it and basically stop it from being able to replicate. So inactivation is actually the more correct and appropriate term for what we do.
Say for a layperson, we would probably just say kill it. But I get what you're saying.
Yes, exactly.
Just the definition of you can't kill something that's technically not alive. And some of us, like me, I feel it's alive because it has DNA, but other people, obviously, it can't live on its own, so therefore can't be alive. I get it. Jim asks, this is a good one. What happens if you lose power to the device? Can contaminants collected be reintroduced back into the space?
No, they cannot. If the device loses power, what's been captured in the filter is ionically bonded. So that will not come off. And so there's no worry from that perspective.
And if somehow the device lost power, but the fan system didn't lose power and it kept running, it would still act as like at least a regular filter at that point, although not an awesome one, but.
Yeah, so if the fan lost power and it was still running, it would basically be killing anything that was on the filter and viable. That's all it would be doing.
All right. Eric says, how effective is this technology at killing pathogens on surfaces?
So it's not a surface treatment technology. What we're doing is we're preventing it from getting to the surface. So Dr. Stephanie Taylor, 2 weeks ago, did an ASHRAE similar to this discussion and talked about the need to continuously clean surfaces. And the reason for the continuous part of it is that the airborne pathogens will continuously deposit on the surface. So if you remove them from the air, then your need to clean the surface decreases. So to answer the question fully, this is not a surface-based killing technology. What we want to do is prevent it from getting to the surface. And of course, if somebody puts it there by coughing or sneezing on a table, there's not going to be any effect as to what lands on the table.
All right.
Ryan, I received a text.
Oh, okay.
With a question of UV versus electromagnetic, pros and cons.
Okay.
So UV systems are very, very effective at killing bacteria and mold on a surface. As long as you have residence time and therefore dosage, it's very effective. However, UV is not effective at airborne inactivation or sterilization. Period. It's not. Your UV system would have to have 90 feet of linear runway in order to be effective on airborne contaminants.
I agree. Normally we only use UV for like evaporator coils, things that are stationary, not moving around. And then you get as much shine time as you want. And you can still certainly use that UV light on an evaporator coil and drain pan in conjunction with SecureAire. Definitely a good idea to put those things together. Mina asks how often these filters need to be cleaned or replaced.
So typically, our filters, again, will last 2 times longer than a standard mechanical. So if your current frequency is a year, we would normally last up to 2 years. So it's less frequent replacement. That being said, filter changeouts are always related to the condition of the space. So dirtier space, more frequent changeout. But that would go for any filter.
Right, and so it'd be recommended that we do it based on pressure drop, either by measuring it manually or having a magnehelic gauge sitting there all the time that's on it. Or
Exactly.
BLS alarming sensor or something like that.
Exactly. And Ryan, to your point, still today, that's the best indicator of life, static pressure.
Mina also asks, filter installation would involve electrical wiring, correct?
That's correct.
And that would,
yeah, it's
go ahead.
It's 120 line voltage, so it's not a difficult electrical install.
Right. And just to be clear, the assembly, the rack, is what we're going to be mounting and installing power on. When you do filter changes later on, you don't need an electrician involved for that. The actual filter doesn't need an electrician. The system initially, when installed, needs an electrician.
Yes, correct.
Dina asks, since code requires certain MERV levels of filtration, is there a rating that can be assigned to this filter?
Yes. So the SecureAire ACS system is MERV 15 rated.
I think I caught up on all the questions. No, as soon as I said that, someone typed another one. Thomas asks, is there any disadvantage of combining this technology with a UVC light?
Disadvantage. As long as the UV is applied appropriately, I don't see a disadvantage.
Well, okay, I'm going to ask a follow-up question then. What would we do that would be inappropriate?
So if your purpose in using the UV light was to keep the front of the coil clean,
Mm-hmm.
it's appropriate.
Okay.
If your SecureAire system is upstream of the coil, so thereby protecting the coil, I'm not sure what benefit you get from additionally using a UV system.
Okay, we have a question from Eric. Has SecureAire seen any advantages and disadvantages to different air distributions, such as unidirectional flow?
To us, airflow is airflow. No difference.
And then as far as the SecureAire assembly goes, I'm assuming we can mount it both horizontally and in vertical distribution scenarios? Or does it always have to
Correct.
be? Okay.
Correct. That's correct. Orientation doesn't matter.
Thomas is asking a question that I'll ask and then I'll clarify. He's asking, UVC kills surface particles, question mark? I think he's asking this because he's thinking of a UVC light installed in a duct system and questioning how could that kill particles on the surfaces in a building, house, or hospital. But what you were saying and what I was agreeing to is that the UVC light kills the surfaces that it's directly shining upon. It'll kill things on those surfaces. But if you install it in your duct system and think it's going to kill something on the surface of your countertop at your building, it is not.
Correct.
I'm assuming that's why I phrased it that way.
Yeah, if you don't have direct contact with that light and the surface and have enough surface time or resonance time, you will not do anything to a live pathogen.
And a lot of hospitals obviously use UVC lights on their coils like we've talked about, but there are some that also use UVC lights in the spaces, like in the operating areas and stuff like that. I'm assuming you've seen that, Frank, and that, I mean.
Yeah, and there have been some interesting studies on those UV lights that are in the operating rooms. And one of the studies actually revealed a higher incidence of skin cancer on the doctors.
That makes sense. I mean, the patient's, okay, no big deal. You're only in there hopefully once. The doctor's in there every week multiple times, so that would make sense. Like going out in the sun all the time, nonstop.
Yep, and typically, right behind in the backside of their necks, where the masks aren't covering them. So that was an interesting finding.
Yeah, it'd be interesting to see if because of studies like that, if they just start putting those UVC lights on in the space when no one's in the space, like in between sessions, and then turn them off.
So that's a great point, Ryan. Some progressive healthcare organizations, some hospitals, use UV robots after the surgeries are complete. And those robots basically go in and scan all the surfaces inside the room, and then they turn them off and they take them out. Problem there is that once you take it out, if there's anything airborne coming in through the air system, you've got to do it again. Is it better than doing nothing? Yes. But we now know that viruses and bacteria can be airborne.
Got to do both.
So, yeah, we need the ability to transport them out. Absolutely.
Awesome. I think we are caught up on all of the questions, unless somebody, whenever I say that, someone always types one in. For those who don't know, SecureAire is represented by TEC here in the Chicagoland area, Milwaukee, Northwest Indiana. So if you guys need help with that, let us know, let me know, let your TM know, let Frank know. We'll help you with any project help you need. We do have several people that are out of state that are listening in, which is also cool. SecureAire does work nationwide. It just wouldn't be TEC helping you, but we can still get you pointed to the right person in your state if you need help with that. With that, Frank, thank you for your time. We really appreciate it, and see you next time.
Yes, thank you, everybody, and be safe.